Hello, everyone.
So, yeah,
Good morning, sir.
good morning.
To authors and invited guests, welcome to Technical Session 10E. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025 Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 17th of July, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Professor Ganesh Bhutkar, who is a professor and assistant head research in the Department of Computer Engineering at Vishwakarma Institute of Technology, Pune, India, with around 20 years of academic experience. He has published approximately 30 research papers and actively contributes to the research community as an associate editor for several international journals and as a reviewer for the International Journal of Human Science Studies. His core areas of expertise include human computer interaction, medical usability, artificial intelligence, and assistive technology. We welcome you, sir.
Yeah, thank you.
Thank you, sir. We'll be proceeding with the paper presentations. I'd like to call upon our first presenter, Anshuman Kishore Mahato, with the paper titled 6G for Resilience, a Framework for Real-Time Disaster Management. Sir, if you're ready, then you may start with the presentation.
Hello, am I audible?
Yes, sir, you're audible.
Yes, you are audible.
A screen visible to you guys?
Not yet.
Not yet, sir.
So should I start?
Yes, sir, you may.
Yeah. So this is a research paper that we have came up with. It's called 6G for Resilience, a framework for real-time disaster management. So basically, the motivation for coming up with this research topic was living in a country like India, where we succumb to mostly disasters in many parts of our country. So an effective disaster management system is quite essential. And looking on to the challenges that we face to mitigate out the disasters is probably an effective communication system. So, what communication system do we have right now, and what are its shortcomings? So, doing coming up with the research, we came up with the thing, or we noticed that 5G networks, which are often used to communicate during this disaster situations, have its own limitations and connectivity issues. So, 6G, which is the successor of the 5G network, can actually help to solve out these issues or mitigate the problems which 5G actually faces. So the solutions that 6G has, it's ultra low latency, massive bandwidth, and terahertz frequencies. So we try to expand out on some of these topics through researching on it a bit. So as I talked about the motivation, that was basically the need to mitigate out some of the shortcomings that disaster management system often faces with the communication issues. So 6G provides an efficient capability uh, while handling those communication systems in disaster scenarios. So while researching through it a bit, we came up with some of the features which 6G might have to mitigate out these disasters. For example, there's a spectral band efficiency. So, for example, 6G uses terahertz bands, and it's a simple Shannon's formula for like calculating the terahertz frequency. And also, it has a very ultra low latencies. So, we ran those mathematical calculations and tested out whether or how much effective the communication could actually get uh, if 6G is actually used. So some of those calculations were made by us, and we came on to the conclusions that 6G might actually be quite helpful while we come up with if we were to apply 6G in some of those disaster related situations. So how were we supposed to implement it? And what are possibly the benefits that 6G might actually have? So there are three basic things that we came up with. The first thing was the network coverage and scalability. So 5G, though it could be scaled very effectively, but let's consider a scenario wherein there's a disaster and 5G doesn't work that effectively when it comes to, let's say, a situation wherein the network coverage is not that good. So, for example, there's certain natural disasters or things like that. So, base station deployment of 5G wouldn't be that good. So there's a coverage probability that actually decreases there. And the research paper actually elaborates on some of these topics about how 5G has those shortcomings and how 6G can actually mitigate it. Then there's this resource allocation thing. Let's say if we are using 6G in place of 5G network, then if there's a disaster management team and they were to communicate with each other, how effectively they could allocate the resources to different areas so that it would help in uh, s- uh, help in actually moving those disaster process in an effective way. Then there's this real-time data transmission. Again, communication is actually a key part. Let's say there's a person who is stuck in somewhere and it's not able to communicate just because of network coverage related issues. So 6G in those situations can actually help because the coverage range is actually pretty pretty effective and it has a bandwidth which is pretty high. So that could also help in sort of mitigating out those issues. Again, mathematical analysis was a key part of this research paper. So what we calculated was, let's say there's a 6G network and a 5G network. Now, how does this two differentiate among each other? So a key analysis was there's a data transmission delay. So anything that has a network comes with a certain delay. So I send a message from one location to another, and then there's a delay that's associated with it. So we ran out those calculations and we calculated a bit of the delay between those two networks, 6G and its predecessors. And we came up with the conclusion about how 6G would reduce this delay. Then there's signal attenuation. It's a simple formula that we have plugged in with the values of 6G. And we came up with the conclusion about how effectively we could track out uh, those signal related issues to improve in, let's say, a certain disaster related situations. Now, where would this actually be applicable? So when I started introduction, I mentioned a scenario like we face disasters quite often. And like this year too, there's been a lot of floods in our countries and a lot of signal systems go down usually. People are stuck somewhere. So basically, in those situations, we actually need to sort of mitigate and or find a certain solutions to those sort of scenarios. So 6G plays a very important and a pivotal role in sort of minimizing those because it helps in improving the connectivity related issues as I presented out in those previous slides. And if it's integrated in a real-time environment, then it could also be used in a very effective and a sort of collaborative and a effective way as well. Then there's adaptive communication. So basically, it could be used for like dynamic beamforming, spectrum allocation of reliability, and performing communication failure by minimizing redundant path. That is also very less prone to failure scenarios and situations. Now, what are the challenges and limitations? The research paper actually also elaborates quite a bit and throws some lights on the limitations of 6G networks as well. It would take a lot of time to implement such a thing, but if it's done once, it would actually be very effective. Then there's a robust infrastructure. The switch from 4G to 5G was also pretty smooth, but the 5G to 6G would require a certain bit of infrastructural change, and that was also elaborated. Then there's some certain cybersecurity and privacy issues related to that. So actually, that was also a key part about how to prevent out certain cybersecurity and privacy related issues. And Then there was a certain thing called standardization and scalability. So we cannot just deploy a certain network in certain places of our country or a certain specific location and call it to be preventing disasters for those particular locations only. So that has to be scaled out throughout the country. It has to be has to be made a certain standard so that it could help in mitigating out the challenges which the research paper actually proposes. So we also mentioned some of these ways about how this could actually be achieved. Now, again, coming on to the actual conclusion of the paper. So I mentioned out some of those formulas there, right? We ran most of our calculations taking into base the current 5G network and the 6G network on which we ran our calculations. So there was a data set which was available to us, and we mostly based our thesis on these data sets itself. So we mentioned it there. So there was a certain emergency call success rate. So what happens when there's a certain disaster stuck in a certain place? People reach out to the emergency services. Now, what are the chances that you are making a call, right? So there's a pre-framework chance of 48%. And once 6G is deployed, the amount of calls that could be handled to the disaster relief crew would certainly spike. And there's the improvement percentage. Now there's the energy consumption. 6G, with its more bandwidth and greater range, you would normally expect it to have a larger energy consumption, but mostly it doesn't. So we ran our calculations on basis the energy conversion equations as well. We came up with this particular number, which is obviously rounded off. Then there's the traffic handling data. So any network comes with a certain flow of traffic. 5G also has its natural traffic bandwidth. So we ran our calculations on the basis of a certain data set, and we came to the conclusion that about 18% would be the post framework, or that is 6G networks traffic handling capacity, with an improvement about 37%. Now there's something called end-to-end latency, which is also important because when two users were to communicate, we keep into account the latency that would come onto account, and 6G actually reduces it to like 1 millisecond which is a lot improved when it's compared to like 5 networks. Then there's the throughput, which would go up to 1 terabytes per second. Compare it to like a 5G network, which mostly remains on the later parts of the gigabits. So then there's reliability and scalability. I talked about how the challenges and limitations were scalability issues and reliability, considering the fact there was the cyber attacks and other sort of things there. But there are shortcomings, though there are shortcomings to like a 6G network, but still there are solutions that we could implement just to help, just to counter out this sort of situations itself. So that basically was it. And then what we conclude here, that 6G network, with help of its ultra reliable low latency communication and its high device density and data speeds, which resulted in a certain results about improving its communication efficiency with respect to 5G networks, which helped it improve quite a lot. So that, and in addition to that, there's a high device density and data speeds, which also helped in reducing the latency and increasing the network flow and coverage. So those sort of things actually helps in the scenario of disaster relief and disaster resilience. So basically mathematical models confirm, and we also ran the mathematical models, and according to that model, we got a certain result. So on basis of that, uh, we tried to integrate the disaster management plan in our country basically to help it protect from like certain things that might occur in the future. So that basically was the conclusion that this research paper tried to convey. Thank you.
Okay, thank you. Thank you very much. I have a question.
Yes,
Okay.
sir.
It was a good presentation. So you talked about the energy consumption. It improved by 42%, you said, right?
Right, sir. Yeah.
So how do you achieve it?
Right, sir. So we actually looked onto the certain energy consumption data about the, let's say, a 5G network or a 4G network, which is currently running, right? And then there's this, we ran our information about the same formula with the same frequency uses or the frequency band that 6G uses on that certain specific formula, and that gave us a certain result that we came up with. So you're specifically talking about how to implement it. So when it comes about implementing, there's a robust infrastructure that would be needed to implement 6G. But if it's done, I guess the energy consumption would certainly match up with our calculations that we came up with.
No, I want where exactly the energy consumption is higher in
Right,
5G and how that is reduced in 6G. That I want. You run the formula and you got something. I mean, that is okay. But where exactly the energy is consumed in 5G, which will be
right,
not consumed in 6G? That I want.
right. So right, sir. So if I go along with like what the data is that we have went through and what are the resources that we have made, so 6G actually uses certain things which is called like uh, let's say the network over which 5G is transmitted, and the frequency ranges that 5G actually uses is different from what 6G is going to use. So let's say the spectral bands or the frequency ranges which 6G is going to use and the infrastructure over which 6G is going to implement. So that would actually make the difference about how the power consumption is actually made. So if you look on to, let's say, how 2G network used to work and how 3G used to work, then 5G came up with a specific frequency band and a more, let's say, a specific network infrastructure. So that led 5G to be more efficient than, let's say, 4G or 3G network. And that also led to, like, let's say, energy reduction.
Okay.
So I think 6G would also implement or incorporate those same network infrastructures and the frequency ranges that might also help in
You
reducing.
have to look into all this. Okay. Anyway, any other
Right.
question from anybody else? Okay, then. Thank you. We can move to
Thank you,
the
sir.
next paper.
Thank you, sir. We'll be proceeding with our next paper presentation. I'd like to call Deep Prajapati with the paper titled A Systematic Review of AI-Driven Personalized Mental Health Interventions. So if you're ready with your presentation, then you may go ahead.
Yeah. Yes, ma'am.
Yeah.
Now, is the screen visible?
Not yet, sir.
Now, ma'am?
Yes, sir, it is visible now.
Yeah. So, hello and good morning to everyone present over here. So, we have basically written a review paper on the topic named as the AI-driven personalized mental health interventions with the authors of Kumar Saxena ma'am, Akshay Raghava, Sharvin Gupta, Archisha, and myself, P. Prajapati, all from Thadamachani Engineering College in Mumbai. Uh, so the introduction to the problem statement which we uh, thought to write about uh, focused on mainly on the mental health challenges which people are suffering nowadays, especially after COVID-19 pandemic. The number of cases have been increased to 970 million individuals, where the spike in common mental disorders such as anxiety and depression have been increased 25% yearly. And according to WHO, which is World Health Organization, the mental health providers or the therapist ratio is very less compared to the number of people facing it. So, according to the 2021 data, it's just 9 therapists per 1 lakh people to attend to. So, moreover, all such issues have been, when addressed, are to just a one size fitting protocols, which just neglects the personalized touch to a proper response under therapy. They always follow a simple and a repetitive kind of recovery patterns, which has been not yet useful. So here is where the enhanced artificial intelligence using various methods can be beneficial for the improvement of these issues. Moving on towards the methods we have used for our literature survey. Firstly, we followed the PRISMA guidelines to ensure that we have been studying the depth of the problem. So for that, I would like to explain is the problem of mental health starts from how they are facing, what they are facing, what they can improve, what are their uh, future plannings to improve it, and the constant repetitive process. Along with that, finding proper materials to have the basic knowledge and what can be implemented via technology, which we have studied and implemented and wrote about in the review paper. So we have taken many good quality papers from various sources, starting from the Beck inventory, which is a standard set of 23 questions, which provides and gives us an analysis of what a person might be uh, thinking or uh, what is their mental health disorder. So from there to going on to various articles such as use of artificial intelligence, the uses of natural language processing, also use of multimodal technology to uh, make chatbots and applications which uh, cater towards the betterment of the AI in these mental health applications. When we studied more in depth about what can be used, we all know about the standard usage of LLMs like ChatGPT or Gemini or Grok, which are being currently used and known by everyone. But as we know, the corpus of their model is based on uh, all the data knowledge of the web. So their responses would be very basic and they won't be thinking like a therapist or someone who might give you an empathetical answer towards what you are seeking for. So for that, there are various tools created which we have found, such as VBot, Vyasa, Talkspace, BetterHelp, which caters towards different parts of mental health problem solving. And it includes such as CBT, TBT. CBT means cognitive behavioral therapy, where the thought processes of a person are continuously changed. Where DBT is a direct behavioral therapy, where one-on-one interaction between the therapist and the user is being taken place. So like that, catering towards very specific part of mental health. There are various AI applications being made, and VBot has stand out drastically, which is been providing excellent answers for CBT-based therapy for depression and anxiety disorders profoundly. Whereas in Vyasa and Talkspace, the open public data was to be found less, and we have came to know that their way of answering is a very uh, standard and very fundamental. Like they follow a rule-based AI model instead of learning on based on continuous uh, sessions. Moving on to the challenges and the barriers which we have found out by reviewing all these applications is that first of all, gathering a big mental health data is of a major ethical issue as sensitive data can be leaked and be used in a wrong way. An example of that would be when Microsoft first launched a chatbot. The users were manipulating their inputs via external sources, and it caused to leakage of various personal data of the users, and it brought a very misleading situation for the company. Whereas the challenges in the AI models faced suffer from biasness because all answers are not being reviewed by therapists. So the AI model trained has to make some guessworks and there can be inaccurate diagnosis. And there is always a lack of multimodal integration where we have also look upon a case study where the natural language generation, a CNN based processing and a voice-based processing was implemented so as to understand the user's problem profoundly and to give more accurate results. So another challenge would be to integrate these AI solutions, how they interact, to implement together into the clinical testing phase, where where everyone tries to achieve not to replace the therapist, but the AI will help to uh, AI will help to find them the proper initial recovering stage, and with the help of therapists, they can improve together, which includes various steps which are not been included in the previous applications which we have shown. In order to conclude, I would like to say that all the applications which we are provided by AI and they try to enhance the traditional knowledge and they lack in personalized and continuous answers which can be scaled if provided got in the right mental health data and the correct ethical use of it. How, and however, the programming of algorithms and the technologies used uh, can be updated to have more profound recurring and reinforcement learning methods. And also to get proper results, the collaboration and integration of various devices such as VR glasses or maybe brain computer interfaces where the nerves of the brain are connected to get the sense of the emotions, or maybe wearable watches to provide some SOS signals along with the detection of mental health can be integrated to have a very profound application which caters to all the needs and not just one specific one. So thank you. That's it.
Okay, thank you, Deep, for your interesting presentation. Uh, so you spoke about this AI-driven, initiative for dealing
Yes.
with personalized mental health, right? So,
Yes.
uh, in this particular domain, for patients, data privacy and security is extremely important. So, how it is
Yes.
handled actually when you are dealing with this AI or generative AI context, where which are data intensive or a lot of data is involved. So what is the
So
status of it? Yeah.
yeah, so when we were looking through all these papers, we found out that the data sources contained from some medical colleges were mentioned but not revealed to the open public. We also tried to request and gain what's their insight, but we weren't unable to find, as they told the same thing, like it's a very important thing not to disclose them. Whereas where we found to learn how those data are being structured. So in order to cooperate the privacy, what they do is the questions and the answers are being tagged as unknown rather than just to mentioning the patient specific data. All patient data are being randomly uh, mixed together in a proper tabular format, which uh, can be used as a can be used as a data sheet for the training of a specific model which we want to use.
Yeah. Okay. So still it remains a challenge.
Uh, yes, sir, because it remains a challenge as the applications which we have reviewed and tried to uh, gain their knowledge about how they have fundamentally developed their application based on which technology, which algorithms, which data frames and uh, data sets. So those were some things which were difficult to find
Okay.
because, yeah,
Okay. Thank you. So the
thank you.
next paper will be presented by Nikita. So
Yes,
that's the
sir.
fourth
Good
paper.
morning. Yeah. Sorry for the interruption.
Hmm. Yeah.
Yeah, I have shared my screen, sir.
Hmm.
Is it visible?
Yes.
Yeah. Okay. Very good morning to one and all. So today, my name is Nikita Patel, and I'm from the Keli Technological University, Hubli. So today, I'm going to present my work on the advanced pothole detection and the mitigation system, along with my team members. So this is the small kind of work what we have done. Uh, As usual, this is our problem statement like designing the pothole detection system, which uses some advanced technology to identify the road hazards as well as alert the drivers in the real-time systems. Finally, the motto of designing this system was to enhance the road safety in order to minimize the accidents as well as risks, so that it should be easily scalable and integrable in the existing autonomous vehicle systems. So the motivation behind this is, as we all know, that roads play a very crucial role in the transportation, which influences the various aspects. It can be the individuals as well as the nation as a whole. So, road safety being a concern issue due to the increasing number of the accidents, there are several reasons for the accidents, such as pothole could be one of the reason. Due to the, significant challenges could be like impacting the safety, transportation efficiency, as well as the economic costs. Thus, we as a small kind of application, we need to design we intended to design the pothole detection system which tried to enhance the road safety by preventing the accidents such as reducing the vehicle damages, so that roads with the potholes can show down the traffic as drivers navigate around the damaged areas, which lead it to causing the conjunction. Detecting and repairing the potholes ensures smoother traffic movement. So the objectives in designing the system were, first is to develop a system which detects the pothole accurately without any human intervention. And the second objective was minimizing the false positives as well as the false negatives to improve the reliability and obtain the high accuracy. So real-time detection of the potholes to support the immediate maintenance actions. When we went through the literature survey, we already have certain systems which have been designed by the various authors, designing these pothole detection systems by using the deep learning models such as it can be YOLO V4, YOLO X, and stereo vision for the accurate identification. So the methods what they had implemented were the image segmentation, disparity mapping, and the drone-based approaches, which try to enhance the detection accuracy and the real-time performance. Usually, the detection accuracy ranges from nearly 85% to 99, which tries to improve the road safety as well as it in turn supports our ADAS systems. Then the techniques what they had implemented were the 3D mapping, geotagging, which helps to detect our track holes and streamline the repair management. So this was a slight amount of the literature survey what we have gone through. Yeah. Finally, I'm approaching at my system design, which this is the functional block diagram what we have designed for our system. So we have collected the data set, sir. Then the data set has gone through the various steps, such as it can, first the collection has been done, and it has to be pre-processed in such a way that the cleaning of the data set has to be done. Then the annotation of the images to be done. Then we have to train the model as well as test it, validate it. Yes, the software what we have used was YOLO V8 to check the performance. Then we created and saved the model. Finally, the prediction was we gave input as a video. Then we tried to inference and label it. So this is the functional block diagram of our design system. Yes. As I have already explained about this, we had collected some raw images which are to be processed for training the model. Then the, yes, image collection was done through the Raspberry Pi camera. So we had captured images using Raspberry Pi camera or the similar device. Then the cleaning means unwanted or low quality images to ensure the data quality. Yes, we had also done the image notation, labeling the images with the bounding boxes or classes or other metadata for training. Yes, then we had trained the data, validated it, tested it. Yes, finally through the YOLO V8, the object detection was trained and evaluated, checked its performance, and created and saved the model. Where we finalized and saved the trained YOLO V8 model for the future use. Yes, so this is the morphological chart what we have gone through. We had gone through, as I have already explained about the literature survey. This is the survey what we have gone through in the 4 papers. And through the functions, we have just segregated the data. It can be with respect to road data acquisition, in the paper one, it was done through camera equipped drone, and the data pre-processing was done through histogram, pothole detection using YOLO V8, its accuracy. In the similar manner, we have gone through the paper 2, paper 3, paper 4. So we had collected and represented as a morphological chart over here. Yes, this is the final design what we have done. I mean, my image was in the form of pixels of 486 into 353, and it has gone through the convolution process where the feature mapping as well as extraction was done. And finally, we gained the output and detected the potholes with certain accuracy, which I would like to explain in my results section. Yes, this is the flowchart. As I have already explained in detail about this system design, this is the flowchart what we have designed for our system for detecting the potholes. Yes, and this is the final results. I would like to stress on the pothole detection was built and evaluated using YOLO V10N model, and V10 model was trained with the dataset with nearly 665 images of the potholes that would simulate the real-world pothole scenarios by using the effects of the shadows, different lighting levels, photographies of the dry and water-filled potholes, and the moving automobiles. Thus, the detection system was evaluated using some several performance metrics, which includes the MEP rate of nearly 0.5 or 0.5 to zero point 0.7, which requires certain precision recall F1 score. Then we have also created the confusion matrix for this and the qualitative results through some sample images. Yes, this is the curves what I have over here. Yeah, and these are the images what we have got through our system detecting the potholes on the roads. And finally, I would like to conclude that the results suggest that the YOLO-based model is almost well suited for the real-time pothole detection applications, and the high recall ensures that most potholes are detected, which is critical in the ADAS systems. However, the moderate precision indicates some false alarms which may require further refinement. Yes, we need to refine moreover our design through post-processing techniques or enhanced training data sets. Yes, so this was my presentation, sir. Thank you. Over to you.
Oh, thank you. Thank you very much.
Yes, sir. Thank you, sir.
So Interesting presentation on this pothole detection system.
Yes, sir.
How the pothole? I have a question. How is the pothole scale identified? You identify there is a pothole, but how big
Yes,
is it, or what type of it? How you identify the scale of the pothole?
sir, can I just what is exactly meant by the scale? What do you I mean? What do you mean by it?
Scale means even 1 inch by 1 inch is a pothole, and 10
Okay.
2 feet by 2 feet is a pothole, right?
Sir, if I just for the very thing for what we have done, this
Hello,
is what I have presented.
I'm not able to hear you. Hello,
Yes, sir.
yeah.
Hello. Yeah.
Answer
Hello.
it
I'm
again.
able to hear you, sir. Am I audible?
Answer it again.
Am I audible?
Yes,
Yeah.
now you are audible.
Yes. So this system has been designed for a very short distance, sir.
What short distance?
I mean what you just now said, sir.
So are you are just identifying there is a pothole. That's it.
Uh,
You are
yes,
not
sir.
identifying the scale of the pothole, right?
Yes, sir. We need to still do the refinement on this.
So currently, what you are detecting then?
We are just detecting the potholes that are on the roads.
So are you detecting how many potholes are there in this image?
How many we have not approached at this, but as you could see in the results, we can.
And
We
in
can
this
just
image, there is one pothole which is missed. Just above these first two, there is a
yes,
pothole
yes, sir,
that is
yes.
missed.
So as I said, the work has to get again refined.
Mm-hmm. Okay, thank you.
Yes, yes, sir. Thank you, sir.
Thank you, sir. We'll be proceeding with our next presenter. I'd like to call upon paper presenter
3.
Hardik Rokriye with the paper titled Asan Master Intelligent Yoga Mat. So if you're ready, then you may start with the presentation.
Hello, I'm ready.
Yeah, sir. Please go ahead.
Okay. Is my screen visible to everyone?
Yes, sir, it is visible.
Okay, so first of all, good morning, everyone. I'm Gaurang Gulane, along with my co-presenter Ishan Chipurwar. We are from IIT Pune. Our paper ID is 838, and the title as Asana Master Smart Intelligent Yoga Mat. This is the overview of the presentation. So let's begin with a simple question. Have you ever tried doing yoga by following a YouTube video and ended up looking like a bristle that forgot its purpose? Well, you are not alone. In today's fast paced digital world, many of us are returning to home workouts. But here's a twist: over 40% of yoga practitioners perform asanas incorrectly. The result: not only reduced benefits but injuries, discomfort, and eventually quitting. So, yoga at its core is about balance of body, breath, and mind. But without proper guidance, the balance is lost. Our team asked a simple question: what if yoga mat could itself guide you like a teacher? Not just tell what pose to do, but how to do it right in real time. And that's how we created Asana Master, an intelligent yoga mat that gives you instant feedback on your postures using sensors, lights, and sound. Now let's talk about the real problem. Most people don't have access to yoga experts at home. Online videos offer no real-time corrections. And worst of all, incorrect poses can cause long-term harm. So we envisioned a solution that is smart, affordable, personalized, and interactive. A mat that becomes your personal yoga instructor. So how does it work? Four sensing registers are embedded where your body makes contact, that is palm, feet, and hips. These sensors detect how you distribute weight in each pose. LED lights give you instant visual feedback, and a buzzer alerts you if you are out of alignment. The brain behind it, that is an Arduino Uno, interpreting all that sensor data in real time. And to take it further, a video tutorials pause automatically if you are not at the right posture, making sure you learn each pose the right way. It's like having a patient, consistent yoga teacher inside your mat, building upon existing solution. Now you might be thinking, don't yoga apps already exist? Yes, but they rely heavily on visual guidance or webcam tracking. These approaches can't sense weight distribution, can't give tactile or auditory feedback, and they lack personalized correction. We took this gap and built something that blends physical sensing with interactive learning, bridging technology and tradition. So this is the literature review of paper we have considered. Okay, so now Ishan Chaburwar will continue.
Hello. Uh, the objectives of our project was uh, to make a responsible sensor mat, to make built-in expert guidance, to make ergonomic and inclusive design so that everyone from any age range can use our mat, which can guide them. And it is affordable and accessible as we have made the complete mat under 2,500 rupees. Next slide. The methodology used. So we used FSR 406 sensors, which detect the posture and the pressure applied on the mat. Then the LED system, so that the pressure, how much pressure the hands or the legs are applied on the mat, so that it gives a real-time guidance. If a pressure less than 0.2 Newton is applied, the LED light won't be on, but if a pressure around 0.2 to 0.8 is applied, then the LED light will be on the 50% intensity, and pressure more than 10 Newton would emit the light with 100% intensity. We have also developed a web application which is connected with the yoga mat, which shows where the posture should be done using the YouTube video. So if you play the YouTube video, so our model is getting the steps, and the LED lights are getting on the particular positions. Coming to the fourth point, we have made the website connectivity for live feedback also. If the posture is not connected, the next step video won't be played. The fifth point, ML model with video guidance. So we have also included a YOLO model, which also detects the posture of the body, and it also shows that are we doing it properly or not. What we have also realized is any person who is not doing the posture correctly uh, can also bypass this. So that's why we have included a model which detects the correct postures too. We have also did user testing with around 10 to 15 people. Uh, yeah. Next slide. So this is the architecture diagram. So if the top uh, rectangular box, the big rectangular box is the yoga mat, and these are the 5 sensors represented with LED lights in the box. So if a person has some posture, so the LED lights will be on, and the person has to follow the lights and give pressure with the hands or the legs. Then this is our system integration diagram, which gives an overview how the project, how the research project is working. The results and outcomes. So we have did a research of minimum 20 to 25 papers, and what we have observed is there is a good idea and good requirement of this product in the market, but there is no research conducted. So what we wanted to do is we wanted to fill the gaps and make a product which is very market compatible. We fulfilled the use of force sensors, which gave real-time force application and which is used to correct the posture and yoga completion. We were also able to integrate video and yoga sync routine with LED notifications to provide guidance to the user through the web app. Next slide. So this is the demo what we have conducted. So as you can see, the user is putting pressure, and at the first the LED lights would be on, and after applying posture, uh, the LED lights would get off. So now the first two LED lights are on, so that it shows user has to apply pressure at this position. And this is the live readings of the force applied. Next slide. These are some references which were more inclined towards the project. We have conducted 25 research papers. We have read those, and by that we came to this conclusion. Thank you.
Okay, Hardik and Ishan. Okay, for interesting presentation. So I have a question. You said you studied 20, 30 papers, something like that, right?
Yes, sir.
Uh, so you did this literature survey.
Yes, sir.
So what gap analysis you observed? Gap analysis in the sense, what is the status, current scenario of this such kind of applications?
Yes, sir. So the current status of this project was
No, not your project.
the whole research was is there are research conducted how to pose only using the ML model. There were systems which were showcasing how the person is detected with the yoga pose, but there were no physical integrations. There were physical integrations just by the mat, but it was not inclined towards the yoga. It was not utilized in a way the yoga mat would utilize. It was used for something else, for physiotherapy applications.
Okay. What is
So
the
what,
accuracy of your system?
sir?
Have you measured? Hello. Do you got my question?
Yes. Accuracy of the system.
Have
So,
you
sir,
measured the accuracy? If you have
y-
measured, then you have the accuracy.
yeah. So, sir, what we have did is we did the testing of this project, and what we found is we were getting 80% results accurate.
Hmm.
The 20% were the error readings if the person is mistakenly applying the pressure on the sensor, or else some heating issues of the sensor were making the value exploded.
Okay. Okay. Thank you. Thank you very much. Let's move on to the
Thank
next
you.
paper.
Thank
Thank
you,
you, sir.
sir. We'll be proceeding with the next presenter. I'd like to call upon Darshil Shah with the paper titled Generating Workplace Insights from Employee Reviews Using Aspect-Based Sentiment Analysis. So if you're ready, then you may start with the presentation.
Yeah.
Yeah, hello. Is my screen visible?
Yes, sir, it is visible.
Yeah. So, good morning, everyone. I just wanted to start with our paper title, which is Generating Workplace Insights from Employee Reviews Using Aspect-Based Sentiment Analysis. My name is Jay Ramani. Unfortunately, my co-author Darshil Shah was supposed to present, cannot present today because he's had some family emergency. So I'm presenting on his behalf. My co-authors are Tanay Kelkar, Darshil Shah, and Devanshu Maheshwari, and Achana Nanade is our mentor. So this is just the general roadmap that we are following for our presentation. I'll start with the introduction. So employee feedback when it comes to companies and jobs is very important. But the problem with employee feedback is that employee feedback can be very scattered, or disjointed, or in many companies is not even taken care of properly. even if we look at job review platforms, like online platforms like Ambition Box, Glassdoor, etc., these platforms provide pretty valuable insights. But overall, there's a lot of unstructured and messy data on these kind of websites. And manual analysis of such data is very impractical just because of the sheer volume of this data. So many people are using traditional sentiment analysis techniques to analyze employee feedback. What do you mean by traditional sentiment analysis is, suppose there is a sentence like the work-life balance of this company is good. That means that the sentiment in the sentence is positive. That means the person is talking positively about the company. But we've taken this a step further. I'll now, just before our literature review, I will explain about how we've taken it a step further by using aspect-based sentiment analysis. Rather than taking the sentiment of an entire sentence together, we have extracted aspects from the sentence and given each aspects their own sentiments. So what that means is, in a sentence like I gave the example of the work-life balance is good, that is just a single aspect, which is work-life balance, which is being spoken about. That is positive. But whatever sentence has multiple aspects. For example, the work-life balance is good, but the company culture is problematic. This is the sentence. So a sentiment analysis model will just look at this overall sentence and give it positive, but it is not accurate because they are talking about two separate aspects and there are two separate opinions on each aspect. In this case, work-life balance is positive, but company culture is negative. So in the literature review, we looked at papers that are doing aspect-based sentiment analysis, and most of the papers we looked at are they are manually extracting the aspects, and just for each aspect, they are extracting the sentiment. But manually extracting aspects is again very time consuming. It can achieve a higher accuracy because you are just giving the model directly the words like work-life balance, but overall it is a more time consuming and a less effective method for employee review analyzation. So I'll just speak about our architecture now. We are using a text-to-text transformer model known as T5 for aspect-based sentiment analysis, which has been trained using a framework known as Instruct APSA. So, like I said, a lot of these, the papers we looked at in the literature review were just manually extracting the aspects and giving the sentiment of the manually extracted aspects. But what we are doing is we are using our model to not only give the sentiments to the aspects, but also extract the aspects. So we are basically doing a joint task that is harder than what is done in other applications. So I'll just explain a little bit about T5. So T5 is the base model. We are using T5 base model, which has 200 million parameters. And we are training this using the Instruct APSA framework. Instruct APSA is a framework that is gives instruction-based learning to the text-to-text transformer model. And I'll explain more about that in the following slides. So this is just a diagram of the architecture where if we give the model any input, the tokenized. Tokenized means it is split into, the sentence is split into individual words and it's converted to embeddings. Embeddings are a numerical representation of the words. And then an encoder decoder system is used. Encoder is a process of converting it to the numerical representation, and decoder is the system of converting it back to human readable words or language. So first of all, how did we get the employee review data? The first thing we did was we scraped websites like Ambition Box and Glassdoor to get this data. And we developed a full scraping pipeline where we just enter a company's name. Like if we enter Google, for example, then we can just extract about 200 reviews at a time. The first 200 reviews on Ambition Box of Google. So this is the flow diagram above of the scraping process where the base URL is extracted, max review limit, which we were using around 200 in most cases. And our scraping architecture uses Playwright, Beautiful Soup, and requests. And also below is a flow diagram that shows our entire process in short. So our review sources were Ambition Box and other publicly available data sources like Glassdoor. First, the scraping process, how the data is stored. Data was then pre-processed, where we cleaned the text. And first, what we did was to train the model. Initially, we had to do manual aspect extraction to show the model that yes, these are the aspects. But once the model learned on the manual aspects, it can now give you the aspects by itself. How the model training and how the model was evaluated, which I'll now continue to show in the next few slides. So the scraping methodology uses playwright and requests beautiful soup. Playwright is used for navigation between the pages of the reviews. The request is used to send HTTP requests to get the data, and beautiful soup is using the different HTML or JavaScript tags to extract the data. And to prevent bot detection in this case, we've also implemented random header changing. What do you mean by headers is HTTP headers. So HTTP headers are basically a set of key value pairs that are sent in HTTP requests, and they are even responsible for connection of client and server. And when a normal human is browsing, these HTTP headers keep changing. But if we are doing a scraping process, technically we are using a bot to get the data. So to prevent bot detection, we have to change headers to make it look like a human is extracting the data. The model fine-tuning process. The T5 model is fine-tuned using the instruction learning-based framework, which is Instruct AppSub. And we gave the scraped data, which was scraped before using the manual annotation process initially. And manual annotation process is basically like, if you look at the sentence below, this running inference on input, work-life balance is good, but company culture is bad. These are the kind of sentences that were there, and these are the kind of sentences that we gave it with manual annotations. So now if we give it the model any sentence, like here we have given it work-life balance is good, but company culture is bad. Here you can see the model output is work-life balance positive, company culture negative. So it is extracting the aspects as well as the sentiments of each aspect. So here are the results that we achieved. The precision, recall, and F1 score results. We achieved across the board around 70%. This was because we were doing the joint task, right? The joint task is aspect extraction as well as sentiment classification. So aspect extraction and sentiment classification is a tougher task than doing just sentiment classification. So our current results are around 70%, but with more tuning, we can increase this. So this is just a chart showing the precision, recall, and F1 score for the top 10 aspects in a certain data set. So, like for example, the top 10 aspects here are work culture, learning, work life, etc. So you can see work culture. For work culture, the precision, recall, F1 score is almost 100% or 1.0, basically for the most common aspects that are on the data set. And after the paper, we even created a small interactive dashboard to visualize the sentiment distribution of different aspects. So for example, here in this chart, you can see there's job security, work-life balance, skill, etc. Green is positive and blue is negative. So for job security, almost 90 reviews have mentioned it in a positive light, but a few more reviews have mentioned it in a negative light, and so on. And orange is neutral. So neutral means no opinion. But mostly the data was positive and negative only. This chart is sentiment trend over time. For sentiment trend over time, we are basically tracking how the different aspects were basically the sentiment was trending over time. Like here on the left side, you can see average sentiment score -1 to 1. -1 is negative and 1 is positive. So if we follow, suppose this light green, this green line for salary, you can see salary, the opinion initially was negative. It was near -1.0 and it has fluctuated over time. How different employees have had opinions over time on basis of salary, and all the top 10 aspects basically. And sentiment heat map is just another way to represent this, where negative, neutral, and positive, and the number of mentions. So I'll conclude by saying we fine-tuned a T5 model with the Instruct APSA framework, where we were providing an instruction-based learning. I'll just explain a little more about the instruction-based system here. Is when we wanted a model output, since this is a text-to-text transformer, we give the model input in text, the model gives us output in terms of text. So Instruct APSA for the model inference part, where we wanted the model output for any sentence we give, we also, despite just giving it the sentence, we also gave it two positive examples and two negative examples. Two positive examples meaning two examples with positive aspects and two examples with negative aspects. So the model, even during the inference time, understands that this is the way it is supposed to give the output format. The output format is what I had shown here. Model output, work-life balance positive, and company culture negative. This should be the output format. So the model, our T5 model was fine-tuned on 2100 records. And we believe that the findings of this work will offer practical value for organizations and job seekers, as they can see which aspects the employees are happy with and might not be happy with. And for future applications, we would like to use larger data sets for a little more robust system. And currently, we are using it only for employee reviews. If we could have wider variations, like use it for product reviews, train it on different kind of reviews. Basically, this system has a wide variety of applications in that area also, which we are exploring. So these are just our references, and thank you.
Okay. Thank you, Jay. So there were certain negative insights identified, right?
Yes.
So which were the negative insights about in the employee feedback or reviews?
That depends on like company to company. Like I had
In
shown that
general, I'm asking.
in general, most companies that we looked into had mostly positive insights only.
But there were negative insights. I'm talking about negative.
Yes, negative in all cases. Like we had some companies where negative was there for job security or salary. Can I just share my screen again and just show
Yeah.
one part? So this is not part of our presentation.
Okay.
Interactive dashboard here, where we've just searched for Google and we've done the scraping and APSA process. So here you can see work-life balance, that
There is a blue
26
part, and that is negative, right?
and positive counts, and 3 reviews have mentioned it as negative, but 26 reviews have mentioned it as positive.
Don't talk about
Same
positive.
thing for
I
all
am
these.
asking you about negative. You are describing positive. Negative.
Yes.
Just tell me
So
what are the negative things.
So here you can see that all of them have slight negative
Okay.
connotations. Like
Okay. I hope you
there is
understand.
nothing specific that is only
Okay.
always negative. Everything will have slightly negative
Okay.
opinions
Next
and slightly
question.
positive.
Accuracy, which appears to be 70%
Yes.
scores, that is appear to be low. What can be the
Yes.
reason not to achieve accuracies of 90-95%?
Yes. So in the literature review, I explained that the papers that we reviewed mostly, I'll just show the presentation again. Mostly did only sentiment classification. Sentiment classification is positive or negative, or in some cases neutral as well. So like this sentence that is there here. The work-life balance is good, but company culture is bad. Uh, what other papers are doing is they were feeding the model the sentence as well as the words individually, work-life balance and company culture. But what we are doing is a little more challenging task. We are just giving it the sentence, and we are making the model extract the words by itself. So there sometimes the accuracy can go low. Like here you can see model output. The model is giving us not just positive or negative. It is giving us that yes, work-life balance is positive and company culture is negative.
Okay, thank you.
Thank you.
Next.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to call upon Shivani D. Anjaria with the paper titled Impact of Hardware Trojan on Cash Replacement Policy. Ma'am, if you're ready, then you may start with the presentation.
Yes, I'll just share my screen.
Sure, ma'am.
Okay, so is my screen visible?
Yes, ma'am,
Yeah.
it is visible.
Oh, thank you. So good morning, everyone. I'm Shivani Devendra Anjaria, and today I'll be presenting on the impact of hardware Trojan on cash replacement policy. So these are some outlines which we'll be going through. That is, first we'll see the introduction, literature review, proposed methodology, and we'll proceed with the results. So here, the hardware Trojan is some malicious addition and modification which is inserted into various circuits and which leads to leak of some valuable information, or it just degrades the performance of the particular circuit. These are some literature reviews which I had gone through, and this is the in some authors have presented the performance of the cache replacement policy. It is degraded by the attack of the hardware Trojan, and they have resolved it using the adaptive cache replacement policies. And the software used over here was multi-tool SIM. And the next paper which was reviewed that is demonstrates the Trojan manipulates the particular data stored inside the memory, and which also this affects the integrity and system coherence. The next paper, the Trojan has been implemented on the FPGA simulation tool, which again degrades the cache cache replacement policies. The next, the Trojan has been inserted into the L1 cache, and which degrades the size and the latency inside the cache replacement policy. And over here, this simulator was used as GEM5. And the next, there is authors demonstrated the leaking of sensitive data with the attack of the Trojan into it. And this also uses GEM5 as the simulator. The next, the hardware Trojan emulation environment focuses on identifying various system vulnerabilities and impacts on the microprocessor. The Trojan impacts on the microprocessor-based systems. So this is the proposed methodology, and in various literature reviews, it was seen only one cache replacement policy is there, and Trojan attacks it and resolution to it. So when year over year, we have used 3 cache replacement policies, that is least recently used, first in, first out, and least frequently used. So over here, whenever the hit ratio goes above 80%, the activation of Trojan is done, and then there is an attack of Trojan over here, which degrades the cache performance, and it brings the hit ratio below 80%. And this Trojan over here is selected as MRU, that is most recently used. And it has been attacked, and the hit ratio comes below 80%. And as soon as the hit ratio is detected that it is below 80%, the removal of the Trojan takes place. And so over here, the original replacement policy is restored again, and with this, the hit ratio gets improved and comes above 80%. So which is a good, like there's less number of cache misses than cache hits. So here is the one of the cache replacement policy that is least recently used. And over here, the cache behaves as which data is being least used, like recently or by the CPU is removed, and it's replaced by the new data coming from the memory. The next is first in, first out. That is whichever data enters first into the cache is removed first. So here, for an example, it can be seen that 0 enters first. So it is replaced by the next data from the memory, that is 4. And then 2 was the first in. So it's just replaced by the next incoming number into the cache. Here it is least frequently used. And this over here, there is a particular counter which sees that which data is being frequently used by the CPU, which is not replaced by the new data coming inside the cache. and which is like least frequently used, depend on the counter value, it is replaced by the new incoming data from the memory into the CPU cache. So the implementation was done on three different systems, that is Intel Core i3, Core i5, and AMD Ryzen 5. All the systems had Ubuntu 22.04 version, and the AMD Ryzen 5, as you can see, it is Windows 2.0 system, and the rest two have Linux OS based systems. And this over here we have used Gem 5 as a simulating tool. So Gem 5 needs minimum of 4 physical cores to get implemented for various use cases. So in i3, as you can see, the total number of physical cores is 6. For Intel i5, it is 8, and AMD Ryzen 5 also it is 8. So by here, this is the results. So we can see the LRU being the initial cache replacement policy in all the three systems. And the Trojan over here is kept common to all the replacement policies that is most recently used. Whenever the cache hit ratio goes above 80%, it is over here you can say it is 84.17 for the first Intel i3 processor, LRU, being the cache replacement policy. Whenever it goes above 80, the Trojan gets activated inside it and it attacks with the replacement of the cache policy, that is from LRU, it goes to MRU, as most recently used. So the cache hit ratio decreases and cache misses increases because of this Trojan attack, which degrades the performance to 50.2%. And similarly for the LRU FIFO, FIFO over here we are getting the initial hit ratio to be 99% approximately, and which is most infected by the attack of the Trojan, that is MRU. It goes to a hit ratio that is 50%. Next being the LFU. Over here also the MRU attacks as a Trojan. The initial hit ratio was 84 approximately, and after the attack of the Trojan, that is MRU, the hit ratio slightly improves, that is with the 84.04 to 84.09, slight increase, but it is increased. So this is because the least frequently used policy it access the memory pattern in such a way that it has a counter. So this counter is very helpful for preventing the cache replacement policy from the attack of the Trojan. So in the next this graph, you can see that the percentage difference of cache replacement policy by the attack of the Trojan. So yellow is the LRU that is least recently used, and it is less degraded by the attack of the Trojan as compared to the FIFO. That is first in first out, it is almost 49% degraded. Whereas for LFU, the degradation is in minus. That is after the attack of the Trojan, it has improved the cache hit ratio, and this is due to the Trojan attacks are like it is prone to LFU. Trojan attacks is prone to LFU. And this is defensive behavior of the LFU because it has counter which sees that which data is least frequently used. It counts rather than as compared to LR, which is least recently used. So by here, the removal of the Trojan is being showed. So the LRU, FIFO, and LFU being the initial replacement policies, which was then attacked by the Trojan and they changed to MRU. After it detects, okay, this is below 80%, then let's get the original replacement policy back into it. So it gets a corrected hit ratio, that is 80 above 84 and 99. It comes back to its original hit ratio. But for the LFU, it doesn't get corrected because the MRU performed better. And it improved the cache hit ratio, so it won't get replaced by its original replacement policy. MRU will continue it. So here are some Gem 5 captured results. Over here, it can be seen that final hit ratio of the LRU is 84.17. After switching to MRU, it is 50.20. Then it is backed, the LRU is backed with the MRU performance has been degraded. This is a screenshot of the Intel i3 processor. Next, we have the Intel i5 processor screenshot where the FIFO was implemented. So it is 99.72 initially. After the Trojan attack, it degrades to 50.25%. And it is initial, that is the difference between the degradation is 49.47. And over here for the LFU, the hit ratio was initially 83.99. This is a screenshot of an AMD Ryzen 5 processor. And after the attack of the Trojan, the hit ratio is improved. That is 84.01. So LFU performed well. Hence, it won't be replaced by the initial replacement policy. So it will be memory only. And this is the conclusion. And so we can conclude that from all the three replacement policies, that is LRU, FIFO, and LFU, the LFU is more prone to the attack of the Trojan, being the MRU. And this LRU and FIFO performed a little bad by the attack of the Trojan because it degraded its cache hit ratio and it decreased approximately 30 to 40%. So LFU is prone to MRU, and the execution time notice for the FIFO is 0.06, and it is most for LFU, that is 0.21 seconds. So these are some references which I had gone through the paper research work. Thank you so much.
Okay, Shivani.
Thank
Thank you
you.
for good presentation.
Thank you, sir.
So I observed that only OS uses Ubuntu
Yes.
and not Windows. Any reason?
No. Yes, because Gem 5 is compatible only to the Linux versions. It's not compatible for the Windows version, Windows OS versions. So Linux was only the tool used.
So it's not possible to do, work with Windows.
No, Gem 5 doesn't support Windows. OS.
So if you want to work with Windows, what change will be required?
We can use Docker software tool, which we can like make a container and then try to do this whole simulation again on Docker using Windows OS.
Okay. Sure. Thank you. Next.
Thank you, sir.
Yeah.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next paper presentation. I'd like to call upon Satej Patil with the paper titled IoT-based Smart Car Parking System. So if you're ready, then you may start with the presentation. Sir Satej. It seems we do not have him in the meeting yet. We'll be proceeding on with the next presenter. P. Sanjana with the paper titled Kala Hita with the design intervention for Bharatnatyam dancers to help with composition and choreographies. Ma'am, if you're ready, then you may start with the presentation.
Is my screen visible?
Yes,
Yeah.
ma'am,
Can
it
you
is
see the
visible.
presentation?
Yes, ma'am.
Okay. Okay. Hello, everyone. I am Sanjana. I am a design student at PS University. So today I'll be talking about Kalahita, a design intervention for Bharatanatyam collaboration. One second. Sorry for the hiccup. Yes. Okay, so let me set the context. For Bharatanatyam dancers, knowing the composition, knowing the poetry, understanding the interpretations that the poet means to showcase, is very much important in order to present or emote that particular dance and do justice to the poetic meaning of it. But these days, there is linguistic challenges. The most famous compositions or very rare compositions are extremely set in olden language, which is hard for us to grasp the meaning of it, and it is lost in translation. And with if you're not showcasing the correct meaning, that means
you're not there are chances of you portraying the wrong meaning of it on the stage, and which is not acceptable for the general audience. So this project focuses to provide accurate translations and insights into traditional compositions. So we observe the user flow. So the user flow is for the senior artist who has experience in this industry and experience when tackling these composition. They stumble upon a composition. They have access to scholars, literature scholars who can decode the meaning for them, and they're able to find appropriate songs. And if they're not able to find the correct music, they get it recorded, and they go ahead and choreograph and they present it. So the advantages they have is uh, they have access to scholars, easy to find music, and they are in a position to sponsor recording of music, which is quite expensive. But upcoming budding dancers are unable to do that, because once they stumble upon a composition, they either go to Google to find the meaning, they approach their guru, but not at all times that the guru is able to help them out, or they try to reach out to a scholar, but then they don't have the connections that they require, and find another composition if none of it works out. And finding music is also equally challenging, because you, they don't find music according to their interpretation and repetitions. They have to uh, spend a lot of money if they want it according to their interpretation, and the money is a lot, and they have budget restrictions. And if at all it works out, they go ahead and choreograph, but there is a little uncertainty of how correctly they have uh, gotten the interpretation right. So, after conducting primary research and conducting tons of interviews with gurus were conducted, interviews with upcoming artists, interview with scholars and dance researchers were conducted, and surveys were also floated to understand the scale of this problem. And through the survey, it's very much important to know that acquiring translations of composition is hard, but how do they do it? People prefer to have a one-on-one conversation with either their guru or scholar, because the depth of understanding is way better than just reading something over online or trying to find it in books. And also, the budding dancers are unaware of the kind of books that are available and which book that the person should approach in order to find a particular thing that they require. And the question was followed up with the accessibility they have to scholars, musicians, and gurus. And you can see that about 30% of them don't have the access that they require. And when once asked if do you find lyrics, notations, and translations easily, you could see people say maybe. There is uncertainty and there is no clarity. You're not sure if the translation that you get online is correct. And yeah, and you can see 26% of them just said yes, compared to said no, compared to the yes percentage, which is extremely low. So after all this primary and secondary research, the pain points that were derived is there is no accessibility to scholars for translations. The online resources are unreliable. They're unaware of the available resources. There are cases where gurus try to gatekeep certain compositions and interpretations for their own personal reasons, and they have difficulty in acquiring music, and there's lack of external guidance in choreography. There is uncertainty, and they find themselves to be less confident in such situations. So these were translated into requirements for this project. It was to make scholars available accessibility easier, ensure making of online resources available and trustworthy, which is very important. uh, the resource availability should be transparent. There should be no gatekeeping whatsoever, because everyone deserves to have the equal access to resources, and feedback mechanism in order to improve their vision and interpretation. So a concept was developed. So a service portal was uh, ideated to get in contact with scholars and have a platform where scholars upload compositions themselves so it has the credibility to it. Creating positive growing atmosphere is very much important because this space is quite competitive, and people are aware of what are the results of competitiveness. And musicians availability is also important. People should be aware of whom to approach for recording a certain kind of music and how much do they charge, and all of this information is important to have. And people should always also have book availability with the table of contact to content to understand what are the books they have to approach, and to understand how are the audience perceiving their composition is also important. So this concept was validated with very famous literary scholars in this space. So once after talking to them, they did validate this concept. Uh, they showed how important it is to reach out to scholars and musicians, as they can just reaching out to them helps them widen the approach, widen the interpretations, widen the creative atmosphere are surrounding that particular composition. And also uh, they also pointed out that ethical practices and fair compensation should be given to scholars as well. There are scholars who are happy to do this for free, but this is a way of living. This can actually generate income for budding literary scholars and help them get their way into the dance space too. So this platform was branded. So the name chosen was Kalahita, which means art well-wisher. And the colors and uh, the style of the branding was selected in a way to uh, represent growth, harmony, and a supportive atmosphere within the platform. So the major features are centralized platform for Bharatanatyam dancers, provide access to scholarly translation. Uh, dancers also during the concept validation, scholars notice that few people are not that serious about the project that they're taking up. So this seriousness should be brought in. So a way to submit proposals to scholars so that they can encourage collaborative atmosphere and support a monetary exchange. So a website was prototyped. So this is the landing page for the website. And this is how the dancers will get onboarded onto the platform. And this is how scholars, musicians, and gurus will get onboarded into this platform. Uh, so this is how the particular dancer will submit their proposal. They'll look up the scholar and their expertise in certain things, and they'll write down their proposal and submit it to them. They have the option to either write it via text or record a video of their proposal and submit it. And the scholars will receive the proposal and they have the option to either accept it or reject it with a valid reason, of course. And if in case the scholar rejects it for some reason, as then they have explored their space earlier or that's not their expertise and they would like to recommend someone else who's better for this particular proposal, obviously there are similar profiles that pop up and they can circulate this proposal to anyone that they like. So this platform was uh, user tested, and people did validate this particular platform. And this requirement is very much necessary because there are platforms that upload online resources, upload meanings, but people find it extremely hard to trust them, and they are clueless as to whether this is correct or not, and there is this fear. So people appreciate this access to scholars because that's very much important. And the uh, the most famous scholars are always busy, and there are scholars that people are unaware of. And in terms of navigation through this website was tested, and the minor tweaks and changes were made to make it more user friendly. And testing confirmed the platform's value in providing translations, expert guidance, and music composition support. So this Kalahita brings in a lot of value. There are no more hurdles to creativity. when you have a certain vision, you should have the resource to present it without any obstacles. It just enhances creativity. There is collaboration, just enhances your entire vision, and you're able to convey to that to the audience in a way much better and a confident manner. And it is effective in preserving compositions. There are old compositions, timeless compositions that are getting lost, and this way you are able to present and conserve these compositions. And in future scope, this particular platform uh, can be used for other dance forms too. This platform can open up a, a way to acquire music composition, a way to collaborate with musicians as well. And this can facilitate online workshops regarding choreographies and how you'll approach a particular composition and the subtlety and nuances of it. This is the end of my presentation. Thank you for listening, and I'm open to any questions that you have.
Okay, thank you. Thank you very much. It's a good platform, Kalahita. Okay. So you mentioned about some interviews. What kind of and how many interviews were conducted, and how useful was the exercise?
What is the last sentence that you said?
How useful was this exercise of
Okay.
interviews?
So, to conduct literature study, there are hardly any research papers published on this particular area because this is a very niche area. So obviously, I had to resort to interviews. So I spoke to about 10 upcoming budding dancers who are at a phase where they've learned the things that they require, and they are in the phase of experimenting new composition, experimenting new choreographies, and they have a vision to interpret. So around 10, and around 5 gurus were approached, and who senior gurus who have done this throughout their life, and scholars. One PhD scholar was approached, who his name is Shatabdani R. Ganesh, and another dance researcher who works at Jain University was also approached. So in overall, about 16 to 17 interviews were conducted to uh, extract as many pain points and go deep into the pain points. Yeah.
Okay, thank you.
Thank you.
Thank you. So, thank you. We'll be proceeding on with the next paper presenter. I'd like to call upon Vaishnavi Chiravande with the paper titled Smart Healthcare Using NLP for Advanced Chatbots and Root Cause Analysis. Ma'am, if you're ready, then you may start with the presentation.
Yeah, sure.
Yes,
Just
we
a
are
minute.
starting.
Just a second. Okay, so before starting our presentation, I'd like to take a moment to sincerely thank the organizers and the entire conference committee for giving us this opportunity to present our paper. Okay, so moving on with the presentation. This is Cure AI, the chatbot we've made. So in the introduction, this Cure AI project is built to provide interactive and intelligent medical assistance. We have used NLP, generative AI, and root cause visualizations. So the main domains of health that our project focuses on are diabetes, blood pressure, skin conditions, stomach ailments. So the basic aim of our project was to simulate a medical consultation by not just responding to the symptoms, but by understanding them, asking the right questions, and offering the analysis. It uses sentence transformers for medical intent classification. It uses Gemini API for personalized interview questions. And we have also used Allo LLM, which is specifically an LLM which is trained on medical data sets for generating medical insights. So these are some of the papers we have researched. Mostly these are papers talking about the other chatbots which are currently in existence, and some of the models which are, trained on medical data sets, which would be insightful to our project. So talking about the problem statement. The thing is, as students or professionals, we often encounter health concerns that don't seem serious enough to warrant like a doctor's visit. But still, it can cause some amount of discomfort and uncertainty. So, unfortunately, if we go online and search upon the symptoms we're experiencing and the leads we're getting, it would be overwhelming. Like sometimes I just search upon like my symptoms and it would be like you have a very serious disease or something. So the main aim was to create a chatbot which would be interactive. It would ask questions back and forth like how we experience in a doctor's consultation. It is not made to subsidize the doctor's appointment, but to act as a helper to the doctors. Like we can just check upon our symptoms and our ailments with it, and it would give a back and forth questioning system. So the objectives were that we have to create a chatbot which will use NLP and semantic embeddings for classification. It will generate personalized interview questions, which we are using Gemini API. We have also fine-tuned Allo LLM, which is already based upon medical data sets, but we have fine-tuned it to our specific, diseases we are tracking, which are the four diseases. And we have also used a key feature, which are the fishbone diagrams. It's basically an Ishikawa diagram in which it's a structure of a fish, and we are given the lifestyle choices, the food we eat, and everything which led upon the symptoms we are experiencing or the disease we have been classified as. So, to further explain the tech stack and the data sets, I'd like to call upon Sharvari.
Yes, this is the complete technology stack we use to build our project. It has basically the four parts: front end, back end, pre-processing, and the databases. For the front end, we use Streamlit, which is a Python-based framework that lets users interact with interface. And then for the backend, we implemented all logic using the Python scripts. We have used two major AI models like Llama Allo 8B, which is core large language model responsible for generating responses, and Gemini API, which supports the secondary AI tasks like enhancing and reasoning, assisting with the complex questions. These models work together to create the medically grounded dialogues. Then pre-processing, before any input reaches the models, like pre-processing is important. So we have used the LangChain, chain, which helps with the text pre-processing and managing the embeddings. Then Hugging Face transformers that are used to extract the intent embeddings that helps in understanding what the user is really asking for. And then the database, which is the ChromaDB, the high performance vector database that allows to search and retrieve the most relevant passage using the semantic similarity. This forms the base for our retrieval augmented generation pipeline, ensuring that the answers are not only relevant but also grounded in medical content. Then, apart from that, we have also used the data sets. Like we have used four domain specific medical databases, each representing the major healthcare category. First was dermatology. The source was the Dermatology Handbook for Medical Students. Then stomach disorders. Then for diabetes, we have used Standard Medical Care in Diabetes by American Diabetes Association. And the hypertension. For blood pressure, we have used standard treatment guideline by the Ministry of Health and Family Welfare, Government of India. These data sets we have used to extract the medical books and official guidelines. On that data sets, we do the pre-processing and annotations, like the text from the books was cleaned and tokenized. then created the supervised learning data sets in the form of prompt and response pairs, then fine tuning the language models, like we have seen the Lemma Allo 8B model. Then intent classification training was done. Symptoms oriented user queries were used to train the regression models, and the vector embeddings for semantic search was done. The same domain datasets were embedded using the models and stored in the ChromaDB database. So yes, then next will be explained by Vaishnavi.
Uh, yeah, so coming to the system architecture of our project, uh, we had our front end with two tabs in it. The first was the interactive chatbot for the user interface, and other feature of the project was the health report analyzer that we can upload a report to the app, and then we'll get insights upon it. So this was all uh, done through the Python file, which had some functions and the functions from the high level files from the like healthcare chatbot and report analyzer files. These files were attached to based on our models, the fine-tuned Llama Allo 8B, which was fine-tuned on our four books, and then we had Gemini to support the responses and human-like interaction, as Gemini is the more advanced AI model for interacting, the easy way that will be understood by the common user. So for the pre-processing of our data, for the image files, the image or the PDF that we upload for the report analyzing, we used PyTesseract, which is the popular OCR library. Then we passed that data as well as the our books data to the LangChain and stored them as embeddings into the ChromaDB as a vector embedding. So this was the high level architecture diagram of our project. Uh, Next slide, please. So the methodology is same as before. Like we have the interactive user interface. For system classification, we use the pretend model from Hugging Face, which was classifying the four health related issues that we were addressing: stomach issue, skin issue, blood pressure, and the diabetes. Then when the intent is classified, then the further questions are passed through the Llama Allo model, which is like trained upon multiple medical data set like PubMed and etc., which are like certified datasets. So we trusted on Llama, and for the human interaction, we also integrated the Gemini API. Then at last we would get from the complete diagnosis of what tests we should get and what kind of doctor we should visit, as this is the pre-assistant say to the doctor. The app's motive was then we suggest some lifestyle recommendations, some treatment plans, etc. Same for the both the features, like we can chat after the reports analysis also, and at last we would get the fishbone diagram based on the interview done by our chatbot of the user. So that fishbone diagram says us like due to what lifestyle conditions you got this, due to what dietary factors you have led to this condition. And yes, the it is dynamically updated via the like anyways how you see a chatbot, the same interface we are trying to produce. Yeah, so Shweta will be saying this.
So, as we conclude, our research shows how the AI-powered chatbots can prove useful in healthcare by providing real-time medical advice. QRAI, our system basically sorts the science, possesses queries, and gives breakdown with depictions. We have used Allo LLM to provide context-based responses, as well as we have integrated Gemini API for generating interview questions for users.
So our systems design is modular that ensures scalability and flexibility, which enables to easily add more medical categories. Overall, QRAI reduces the workload on healthcare providers and improves user experience with fast and smart insights. Next slide, please. Our future plans for this system are, as currently it supports four categories of health conditions. Those are diabetes, blood pressure, skin diseases, and heart issues. So we are definitely into extending and exploring more medical areas. Next, to enhance our accuracy, we would be using fine-tuned models like, let's say, BioBert or Made Palm by Google. Next, we have made multilingual support. That is by integrating more languages so that the system could reach to more users. And next is our next future goal is to integrate real-time medical databases like MedLive, Drug Bank. So there the information gets updated timely. And lastly, exploring the Android development for our system so that we can provide on-the-go healthcare support. Next, we have references. Next slide. Aditi. So these are the references. These are the latest papers that we have referred to. And yeah, thank you. That was all about our presentation. We are open to your questions. Thank you.
Okay, I have a question. So basically, nice presentation. Chatbots are generally very domain specific. They have very narrow domain, but it appears to be little generalized. So how do you handle this generalization in case of chatbot?
So actually, we have used the generalized model, and this was the project with the collaboration with the industry, P combinators. So they asked us to narrow down our interest towards the four diseases only, for the stomach problem, for the diabetes, for the skin issues, and for the hypertension, like blood
Anyway,
pressure.
all of these are completely different. They are targeted towards
Yeah, so
different parts of the body.
that's
These
why only
issues are
we
very
chose.
diversified. That's why I asked this question. Go
Yeah,
ahead.
so that was our company's requirement, so that industry's requirement. That's why we like choose the most generalized and effective model, that is Alloy LLM, sorry, Alloy Llama 8B. So, and we fine tuned it on the four medical books that are used in AIMS and all, uh, to uh, like narrow down our focus towards these four diseases. And then we use the intent classification, like if the person is saying, say, I am feeling a, a sore burps or something,
Okay.
so that will be classified to stomach, and then the further discussion will on.
Okay. How it is validated or tested? Is it validated or tested? How you say that it is accurate?
So for now, like for this presentation, we like on the reviews of the Alloy, and like joining it to the Gemini, we did that. But like ongoing, they have, the company has started towards the deployment, and they are gonna like test it with some users and experience. So this is their task.
Okay, thank you. Next.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to call upon Rucha Theodar with the paper titled Vision-Based Real-Time Indian Sign Language Detection. Ma'am, if you're ready, then you may start ahead.
Hello. So I will be basically taking over for Rucha. I'm
Sure, ma'am.
audible, right? Yeah. Okay. So good morning, everyone. I hope you can see my screen.
Yes, ma'am, it is visible.
Yes. Okay. Good morning, everyone. I'm Ananya Bhatt, and I'm pleased to present to you today our paper titled Vision-Based Real-Time Indian Sign Language ISL Detection. This work was carried out in collaboration with my co-authors Rucha Diodar, Tanya Gadwal, Aditi Hinge, who are all present on the call, as well as our mentor Shilpa Pant ma'am. In today's presentation, I'll be walking you through the key points of our work, which aims to bridge the communication barriers faced by 63 lakh hearing impaired Indians. So recently, under the National Education Policy, Indian Sign Language has been standardized, meaning that in a few years, it would be taught across schools to all students. This makes systems that bridge the gap between the hearing impaired and non-impaired people an important domain that requires innovation. While significant research exists for American Sign Language, Indian counterpart remains vastly underexplored. Notable research with it includes the use of CNNs and random forest models, which have achieved higher accuracy for static signs. More complex models such as YOLO V3 and DenseNet have been used for real-time gesture detection with more than 99% accuracy for static gestures. MediaPipe and GRU models have improved tracking for dynamic signs. But most of these systems only recognize individual words or letters, failing to create meaningful sentences. There currently does not exist a system in the Indian market that is able to semantically translate gestures into meaningful sentences. Our work addresses this critical gap by introducing semantic sentence formation by leveraging GenAI. In order to get the system up and running, we required datasets that consisted of both static and dynamic signs. Static signs are basically hand shapes and positions that represent letters, numbers, or words without movement, while dynamic signs involve hand and body movements to convey meaning. For our sign language recognition system, we utilized two distinct approaches. Static signs were trained using a comprehensive Kaggle dataset containing 79,200 images of letters A through Z and numbers 0 through 9 with MediaPipe hands detector processing each frame and normalizing the coordinates relative to the hand's bounding box to maintain consistent shape and positioning. Dynamic signs required a custom dataset of 14 gestures spanning greetings, identity markers, temporal concepts, and actions, with each gesture captured as a sequence of 30 frames. To ensure data quality, we implemented moving average filtering to reduce noise and jitter, applied background subtraction for subject isolation, and converted OpenCV's BGR format to RGB for MediaPipe processing. The system extracts 21 key points per hand and 468 facial landmarks, which are combined and flattened into 1D arrays stored as .npy files. Given the limited size of our dynamic gesture dataset, we enhanced model robustness through time series specific data augmentation techniques, which included time warping through random frame repetition or skipping to simulate natural signing speed variations, and Gaussian noise addition to landmark coordinates to reflect realistic hand and face movement patterns. Additionally, we developed a motion detection algorithm using frame differencing to intelligently trigger data collection only when participants are actively performing gestures, ensuring efficient and relevant data capture. Moving on to the architecture of the system, for static signs, we have used a CNN LSTM model, CNN to extract spatial features and LSTM to handle sequential data for training. The model begins with a one-dimensional convolutional layer comprising 64 filters of size 3, followed by a max pooling layer. This is designed to detect local patterns in the input gesture sequence. The output from this layer is then passed through an LSTM layer with 128 units, enabling the model to capture temporal dependencies across the sequence. To mitigate overfitting, a dropout layer is added. A fully connected dense layer with 128 neurons and ReLU activation further refines the feature representation. Finally, the softmax activation function is used for classification, assigning each input to a specific gesture class. The model is then trained using the Adam optimizer with categorical cross entropy as the loss function and accuracy as the evaluation metric. We train the model for 50 epochs with a batch size of 32, ensuring stable and effective learning. For dynamic signs, a bidirectional LSTM architecture was used, which we refer to as a GestureNet model. The model architecture begins with an input layer followed by two stacked bidirectional LSTM layers containing 160 and 96 units respectively. This configuration enables the model to effectively extract temporal patterns from both forward and backward directions of each 30-frame gesture sequence. To enhance learning, the LSTM layers are followed by two fully connected dense layers with 256 and 128 units, utilizing leaky ReLU activation and batch normalization for improved performance. To address overfitting problems, dropout layers and L2 regularization are applied between the LSTM and dense layers. The final classification layer consists of a softmax activated dense layer with 14 output units, which correspond to the gesture classes. The model is trained for 200 epochs using Adam Optimizer with early stopping based on validation loss. To ensure robustness and generalizability, we have used 5-fold stratified cross-validation, which helps mitigate dataset size limitations and class imbalance. For real-time gesture detection, each video frame is first processed to detect hand landmarks, followed by feature normalization using a pre-trained scaler to maintain consistency. To enhance both visual clarity and hand recognition accuracy, we apply a combination of background-only blurring and skin color segmentation. The background is selectively blurred using a media pipe-based hand mask, keeping the hand in focus while softening the surroundings. This mask is further refined using skin color segmentation to isolate skin tone regions, reducing false blurring and improving the recognition. A 3-second adjustable timer is incorporated into the recognition system, giving users ample time to perform each sign before analysis. Once a gesture is complete, the system requires approximately 40 milliseconds to process the input, recognize the sign, and display the corresponding output. Now, here's where our research truly innovates. Recognized gestures are buffered and sent to Olama 3.1 LLM via API. The model processes these individual words and creates semantically accurate, contextually meaningful sentences, moving beyond simple word-level recognition to actual communication by applying the rules of Indian Sign Language. We evaluated our semantic output using multiple metrics such as semantic similarity, fluency score, etc. We observed a semantic similarity score of 0.78, a near perfect fluency score, and values close to 0.90 for NIST and fuzzy token set ratio scores. This demonstrates that our system prioritizes semantic equivalence over strict lexical overlap, which is crucial for sign language communication. For static gesture recognition, the predicted letter is added to a buffer which forms the word. Similarly, for dynamic recognition, sentence retrieved from the Olama 3.1 call is stored. These are then passed to the PyTT-SX library, which converts the word or sentence into speech. The advantage is its non-reliance on internet connectivity, which enhances accessibility for users. The trained CNN LSTM model achieves high classification accuracy. The training accuracy of the model is 98.59%, while the testing accuracy is 98.47%, indicating a strong generalization to unseen data. The GestureNet model has very good classification accuracy. The final training accuracy for the model is 99.008%, and the validation accuracy is 96.83%. This is a comparative analysis of other models, and as you can see, our proposed system performs as well or outperforms the state-of-the-art models. Next, we see a person sign the letter T, which is added to the pre-existing buffer along with the letters C and A to give us the word cat. That was static sign. And now here we have a person signing the word Indian and then the word woman, which is added to the buffer to give I Indian woman, which gets converted to the sentence here, I am an Indian woman. This also, both these static and dynamic signs have audio output as well. So to conclude, our system is a real-time vision-based system that recognizes Indian Sign Language gestures and converts them to semantically accurate sentences by leveraging GenAI. However, there are still some research gaps that needs to be covered. Our system has two models for static and dynamic signs respectively. Having a combined model that recognizes both these signs is necessary. Our system has a very small data set compared to the expansive vocabulary for which we increase the size to include a more comprehensive vocabulary. India is a diverse country where many languages are spoken. So we increase accessibility by converting the sentences formed into regional or vernacular languages. These are some of the references that were used to make this PPT as well as the paper. With that, I would like to conclude and open the floor to any questions.
Okay, so what is the accuracy of this system?
It has two signs. So both static and dynamic, right? For static, it is 98.59 training accuracy, and testing is 98.47. And for the gesture rate model, that is the dynamic, it is 99.008 and 96.83
Oh my God.
validation.
It is higher in static. Sorry, dynamic than the static.
Yeah, which is also
Why?
our reason behind using two different systems. Sorry, it's two different models.
Actually, 99 is very high accuracy. Very high.
Sir, if I could add in, the 99% accuracy is actually a training accuracy. The testing validation accuracy is still a little bit lower. It is around 96%. So you could consider 96% as
Still, even
the
96% is
accuracy.
very high. Anyway,
That might be because of our data set. We have a very limited 14 sign data set in which we custom collected. And that might be one of the reasons why our accuracy is as high as it is.
basically, you have two small data set and you are, using it
Yeah.
during training also, and similar in, testing also.
We did use five-fold stratified training to ensure that our model wasn't overfitting. So that is a measure that we took to counter the
But
fact
still,
that our
if
data
data
set
set is
is
small, it
restricted.
directly affects the accuracy. You have higher accuracy. Anyway,
Correct.
second question is, how do you compare it with American Sign Language? Indian sign languages are there, American Sign Language, which is international sign language. Are you aware of American Sign Language?
Sir, so American Sign Language, right, is fundamentally different. You sign American Sign Language using one hand. Indian Sign Language, on the other hand, is a language that is signed using both of your hands, and it has facial features to it. So more research has been done for ASL, and ISL is more of an upcoming thing. There has not been a lot of research done in it. So this is one of the things that could bridge the gap in the
Okay.
hearing impaired community.
Thank you. Thank you very much.
Thank you.
Yes.
Thank you, sir. Thank you, ma'am. I'd once again like to ask for Satish Patil. Sir, if you're ready, then you may start with the presentation.
I don't think he is there.
Yes, it seems he's not there, so that brings us to the end of the presentation session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair, Dr. Ganesh Phatkar, for chairing the session. A token to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Okay. Thank you. Thank you very much.
Thank you, sir. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Please send me the certificate as
Sure,
well as
sir.
the snap
Sure, sir.
at earliest,
Yes, sir.
immediately, as if possible.
Sure, sir.
Okay. Thank you.